Good morning to all of you. Today I am here to discuss something about operating system concepts. Okay, this is the rough diagram of operating system concept. Before going to operating system concept, in the last class we have seen the introduction of operating system. At the same time, we have already seen the types of operating system also. Now in this class, let's see the operating system concepts. Okay, so we have already seen that what is an operating system. What exactly is an operating system? An operating system is nothing but an operating system acts as an interface between the computer user and the hardware components. Okay, so what exactly is an operating system? An operating system acts as an interface between computer user and the hardware components. Okay, so here it is very clear that the operating system is acting as interface between human user, means computer user, and the hardware components. Okay, so here we have an application software as well as system software. Now let's see what's an application software or what's a system software. Before going to that, let's see what's a system software. System software. So what's a system software? What do you mean by a system software? A system software is nothing but a system software is a software which is installed when we install the operating system. When we install the operating system inside the computer, okay, when we install the operating system inside the computer, the system software is automatically installed. Okay, some of the examples of system software is compiler, interpreter, loader, linker, etc. There are a number of examples for system software. So these softwares were installed. The user need not install these software separately. When the user installs the operating system in his computer, automatically the system softwares are installed. The examples of system softwares are compiler, interpreter, loader, linker, etc. All these are examples for system software. And coming to the application software. What exactly is an application software? What exactly is an application software? So what exactly is an application software? Application software is nothing but the softwares which were installed inside the computer based upon the user requirement. The softwares which are installed inside the computer based on the user requirement. Okay, so the examples are, for example, if you see web browser, there are different web browsers are there, like Firefox, Mozilla Firefox, we have Google Chrome, we have Internet Explorer, etc. We have different web browsers are there. Whatever the web browser the user wants to install, or whatever the web browser the user wants to use in his or her computer, based upon the user requirement, they will install that particular web browser. Okay, so the web browser is the best example for application software. And one more example is MS Word. Okay, MS Word or MS Office. Whatever the MS Office version the system or the user wants to use in his or her computer, that particular MS Office version they will install in their computer. Okay. And one more thing is the media players. Media player. We have different media players over there. Whatever the media player the user wants to use in his or computer that particular media player he can install inside the computer. Okay, we have different media players over there. VLC media player, Windows media player, etc. We have a number of media players over there. So whatever the media player he wants to install, he can install in his or her computer. Okay. So here what exactly we are going to discuss is, we are going to discuss about operating system concepts. In operating system concepts, okay, So we have already discussed what exactly is an operating system. Once again, what exactly is an operating system? An operating system is nothing but it acts as an intermediary or it acts as an interface between the computer user and the hardware components. Okay. So here we have seen what are the hardware components. What are the hardware components? All the computer peripherals. All the computer peripherals. All the computer peripherals comes under hardware or system hardware or computer hardware. So we have different I/O devices, we have CPU, RAM, etc. All the hardware, all the computer peripherals will come under hardware. Coming to the system software, we have discussed what is the system software. System software is nothing but the software which is installed by default whenever we install the operating system. Whenever we install the operating system inside the computer, these system softwares were automatically installed. They were system softwares. Coming to the application software, application softwares are the softwares which were installed based upon the human requirement or user requirement. Whatever the user wants to install in his or her computer, based upon his requirement, they will install that particular softwares inside the computer. Those are application software. So the human user, the humans or the computer user, they will interact with the system. They will make the system use or they will utilize the resources of the system with the help of operating system. Okay. Now let's see one more example. Okay. So if you see, inside the computer we have CPU is there. Next to CPU we have cache memory. We have CPU. Next to CPU we have cache memory. Next to cache memory we have main memory. Next to main memory we have secondary memory. So all these are interlinked with one another. Okay. CPU, cache memory, main memory, secondary memory. Okay. So the CPU, inside the CPU will have some registers. We call them as CPU registers. What's a register? A register is a temporary storage device. What exactly is a register? A register is a temporary storage device. We have different registers inside the CPU or inside the processor. We simply call them as CPU registers, okay, or CPU registers or processor registers. What are those different registers? They were accumulator AC, they were program counter PC, they were instruction register IR, they were memory address register and memory buffer register. This can also be called as memory data register. So CPU, next to CPU we will have cache memory. Okay, cache memory lies closer to the CPU. Okay, CPU or processor. So don't get confused with that. In operating system and computer organization subjects, we will be using CPU or processor. Both mean the same. Okay. So next to CPU we will have cache memory, and next to cache memory we will have main memory, and next to main memory we have secondary memory. Okay. So inside the computer we will have computer registers. What's a register? A register is a temporary storage device. Okay. We have different registers. Okay. These are different registers. Accumulator, program counter, instruction register, memory address register, memory buffer register or memory data register. First we will see what is accumulator. What is accumulator? Accumulator is a register which stores, which holds or which stores the immediate results. Okay, whenever we execute any instruction inside the computer, we will get an output. That output or result will be stored inside the accumulator. And after that, if we execute another instruction, okay, that result will be stored in the accumulator. The previous result will be erased and the current result, current instructions result will be stored in the accumulator. So the name itself, we have specified that what's a register? A register is a temporary storage device. A register is a temporary storage device. So here What exactly is an accumulator? An accumulator holds the immediate result. Okay, that is the use of accumulator. Next, coming to the PC, program counter. What is PC? PC is program counter. The address of next instruction to be executed. PC holds or program counter holds or stores the address of next instruction to be executed. Program counter holds the address of next instruction to be executed. And what is IR, instruction register? It holds the data of current instruction which is being executed. IR holds the data of current instruction which is being executed. That is IR. Then what about MAR, memory address register? Memory address register holds the address of current instruction which is being executed. MAR, memory address register, holds the address of current instruction which is being executed. That's the use of MAR. Coming to MBR, memory buffer register or memory data register, both are one and the same. So memory buffer register or memory data register, this holds the data present in this address location. In memory address register, there will be an address. In that particular address, there will be some data. Okay, whatever the data present in that address location, that data will be stored in this memory buffer register. Okay, so this is about registers. Okay, right. Coming to the if you want to specify in detail regarding this, okay, we'll see an example. We'll see a small example. Okay, suppose CPU is executing instruction 1. Okay, we have different instructions, instruction 2, instruction 3. Let us suppose there are 5 instructions, instruction 1, 2, 3, 4, 5. Suppose CPU is executing instruction 1. Okay, so while executing instruction 1, okay, so instruction 1 address will be stored in the IR, instruction register. Instruction 1's address will be stored in MAR, memory address register. Instruction 1 data will be stored in MBR, memory data register or memory buffer register. Next, what is AC? AC holds the immediate result. Accumulator is nothing but it holds the immediate result. So when we execute instruction 1, whatever the result we get, that result will be stored in accumulator. What about PC? Program counter holds the address of next instruction to be executed. So CPU is currently executing I1. So the address of next instruction to be executed is I2 is the next instruction. This I2's address will be specified, will be stored in program counter. Okay, this is something about registers. Okay. Okay. So now coming to the concept. So CPU consists of some registers, that's okay. Okay, now what happens is, suppose if there are some set of instructions to be executed, let us suppose there are some instructions like I1, I2, I3, I4. Let us suppose there are 4 instructions to be executed. They were I1, I2, I3, I4. So CPU is executing instruction I1. Let us suppose CPU is executing instruction I1. Okay. So now what we have to do is, while executing instruction I1, all the information related to I1, all the information or all the data related to I1 should be stored in the cache memory. Okay. Right. After that, if CPU is executing instruction 2, the same. all the information related to instruction I2 should be stored in cache memory. Why? Because when CPU is executing instruction I1, meanwhile, if CPU needs any data, CPU immediately refers in cache memory. So be careful. When CPU is executing instruction I1, when CPU is executing instruction I1, meanwhile, if it needs any data, it will immediately refer in cache memory. If the data is available in cache memory, CPU will take the data and the execution will be completed. The execution will be continued, sorry. Similarly, again, while executing instruction I1, meanwhile again it needs any data, again it will refer in cache memory. If it is available, again the execution will be continued. If the required data is not available in cache memory, when CPU searches the required data in cache memory, if that required data is not available in cache memory, what happens is CPU will search in main memory. If the data is available in main memory, that will be transferred from main memory to cache memory to CPU. Similarly, if whatever the data the CPU wants, if the data is not available in main memory also, then the CPU will search in secondary memory. So now the data will be transferred from secondary memory to main memory to cache memory to CPU. It's a time taking process. Okay, that's why in order to avoid the time taking, or in order to improve the system's performance, what we do is, whenever the CPU is executing any instruction or any program or any process, whatever the data related to that process or that program or that instruction, that should be kept available in the cache memory. Okay, so here we have a concept like hit ratio. Hit ratio. What is hit ratio? Hit ratio is nothing but when the CPU is executing any instruction or any program, meanwhile if it needs any data, it will search the data in cache memory. If the data is available in cache memory, we call it as hit. If the data is available in cache memory, we call it as hit. If the data is not available in cache memory, then we call it as miss. What is hit? When the CPU is searching for any data while executing any instruction or any process or any program, if CPU wants any data, it will immediately search in cache memory. If the data is available in cache memory, we call it as hit. If the data is not available, we call it as miss. Then what about hit ratio? Hit ratio is nothing but total number of hits by total number of hits plus miss. So this is hit ratio. Hit ratio. If the hit ratio is more, automatically we can say that the system's performance is improved. Okay, if the hit ratio is more, we say that the system's performance is good. If the hit ratio is less, we say that the system's performance is degraded. We need to improve the system's performance. Okay, so this is about hit ratio. Okay, so here these are the operating system concepts, and before going to that, we also discuss one more thing. For example, there were zeros and ones. Okay, if we represent our decision with zeros and ones, we can't understand. That's why, so the operating system is giving us a privilege to represent zeros and ones as false and true. True is indicated with 1, false as 0, or 1 is represented with yes, 0 is represented with no, or off and on. On is representing 1, off is representing with zeros. Okay. See here, what exactly we are trying to define is, what exactly we are trying to define is operating system is playing a vital role in our computer. Without operating system, nothing is possible. Okay. See here, for example, if Narendra Modi comes to our area for a meeting, Narendra Modi is familiar in speaking Hindi, whereas our local people, they are familiar in Telugu. So in such situation, what we need a translator. Yes or no? We need a translator. What is the job of this translator? This translator will understand. Okay. So Narendra Modi is our PM, our honorable PM. So our honorable PM's speech will be translated into our local language. It is nothing but Telugu. Okay. That is the use of this translator. Similarly, here also we have different translators were there. Okay. We have translator, we have compilers, interpreter, we have a linker, loader, etc. Okay. All those softwares were being serviced or were being provided by our operating system. Okay. The operating system is interrupt driven. Okay. So here we have a number of things. So the operating system is providing number of things like a compiler, interpreter. What is the use of compiler or what a compiler does? And a compiler is useful or helpful for converting the high-level language to low-level language or high-level language to machine understandable language. Okay. And what is the use of interpreter? What is the difference between interpreter and compiler? Interpreter also does the same. It also transforms or it also converts the high-level language to low-level language. But whereas a compiler will convert the high-level language to low-level language all at a time. The entire program will be converted into machine understandable language at a time. Whereas an interpreter, what it does is, it will convert line by line or statement by statement. Okay. So we have a linker, loader, etc. Okay. So all those are being provided by our operating system only. Okay. So this is system software. We have discussed a system software. System softwares are installed on the computer when operating system is installed. So whenever we install the operating system, these system softwares are automatically installed. Similarly, we have discussed system software is a type of software which acts the interface between application software and system. So we have already discussed. Some of the examples are compiler, assembler, debugger, different drivers, etc. Similarly, application software. Application softwares are nothing but they are installed based upon the user requirement. See, application softwares are the type of software which runs as per user request. Based upon the user request, whatever the softwares the user wants to use in his or her computer, based upon their interest, those softwares will be installed. See, examples of application softwares are word processor, web browser, media player, etc. See, we have different web browsers were there. Okay, whatever the web browser we want to use, we means the user. Whatever the web browser the user wants to use, that particular web browser he or her will install in his or her computer. Similarly, media player. We have different media players are available. Whatever the media player the user feels comfortable, based upon their comfortness and based upon their convenience, they will install that particular media player in their computer. Similarly, this is something about, see here, the operating system is acting as resource allocator. The operating system is acting as resource allocator. Resource allocator means, for example, see, the operating system is able to link number of things. For example, we have a computer, it is connecting printer, it is connecting the scanner, okay, and it is connecting speakers, and hard disk, keyboard, mouse, USB port, number of things. It's a resource allocator. Whatever the resource the user wants to utilize. For example, if the user wants to take a print, it is providing printer resource. It is allocating the printer resource. If the user wants to use earphones or headphones connected with the computer, yes, it is providing that resource. If the user wants to watch the movie, yes, it is providing that resource. If the user wants to scan some documents, it is providing that resource. So we are simply calling it as a resource allocator. Okay, an operating system is called as a resource allocator. Okay. So these are some of the benefits of operating system. So it is providing abstract resources like sockets and IPC, interprocessor communication. Okay. So this is something about our topic, operating systems or operating system concepts. This is today in this class we have seen something about the concepts of operating system. Okay. In the next class we will see the topic like operating system services. Okay. Thank you.